In this lesson we're going to look at molar concentrations. It's often very important in chemistry to know the concentration of a particular solution that we're trying to prepare. Particularly, for example, if we're talking about acids or alkalis, you need to know whether the concentration of the solution is strong or weak. So a molar concentration is a way of defining the strength of a solution. Let's suppose, for example, in this teaspoon I've got some caustic soda, sodium hydroxide, and I'm going to prepare a solution of sodium hydroxide by adding it to, say, 250 millilitres of water. So I've got, say, 20 grams of caustic soda, and I want to know what is the concentration of the solution. Well, there are two ways in general that I can do this. The first way is to determine the concentration in terms of grams per litre. Now, in modern day chemistry, the unit decimeter cubed is often used to replace litre. But I prefer the unit of litre as it's used more in common everyday language and it kind of makes more sense. So we're going to use grams per litre and moles per litre in this lesson. So to calculate the concentration in grams per litre, we're going to carry out a rule of 3. So we say that we're taking 20 grams of sodium hydroxide and we're adding it to 250 millilitres of water. Now, we can't mix the units because our concentration is given in litres, so we need to write this quantity in litres, not millilitres. So we're going to rewrite this as 0.25 litres. You remember you need to divide by 1,000 to convert from millilitres to litres. So we say that we have 20 grams of sodium hydroxide is added to 0.25 litres. But what we want to know is the concentration in grams per litre. So we ask ourselves, in that case, how many grams, x grams, do we need to add to 1 litre? We then cross multiply x times 0.25 x equals 20 times 1, 20, and x will therefore equal 80 grams. So what we're saying is that if 20 grams are added to 0.25 of a litre, then the same concentration requires that 80 grams will be added to a litre. So our concentration in grams per litre is 80 grams per litre, or 80 grams per decimeter cubed. Now that gives us the concentration in grams per litre, but what we really want to do in this unit is give the concentration in terms of moles per litre. So to do that, we have to find out how many moles of sodium hydroxide there are in 20 grams. That's the first step. So we need to write out the relative formula mass for sodium hydroxide, which will be 23 for sodium plus 16 for oxygen plus 1 for hydrogen, which will give us 40. Okay, so the relative formula mass for sodium is 40. That means that we can make this statement now that 1 mole of sodium hydroxide molecules, if you like, weighs 40 grams. Then our next question is, how many moles will weigh 20 grams? We then cross multiply 40x equals 20. So x equals 0.5 moles. So in that teaspoon there is 0.5 moles of sodium hydroxide. We then do another rule of 3 to calculate the molar concentration. We say that 0.5 moles of sodium hydroxide, arrow, added to 0.25 litres. But we want to know how many moles are added to 1 litre. So we write x mole goes to 1 litre, cross multiply 0.25 x equals 0.5. Let's make a bit of space, and that gives us X is equal to 2 moles. So what we're saying is that there are 2 moles added to 1 litre of water. So we write the concentration of the solution as 2 moles added to 1 litre. That's 2 mole per litre. Now notice that you don't write the E here when you write out the units for molar concentration, so it's just left as that mol per litre. And I should also have written here concentration too, that this is 80 grams per litre. So these are basically 2 ways of telling us the concentration of a solution. One as grams per litre and the other as moles per litre. So let's consider another situation that involves molar concentrations. Okay, supposing in this situation in the lab, for example, you have a 250 milliliter beaker of water, and I ask you to make a salt water solution with 3 moles per litre. So your question is, in that case, how much salt do I actually have to add to that beaker to get this concentration? So what we're going to do is we're going to divide this problem up into 2 separate rules of 3. First of all, we're going to say that the concentration of the solution that we want must be 3 moles per litre. That means that if I have a litre of water, then I must add 3 moles of salt, table salt, to that litre. But in this particular case, we've only got 250 millilitres, which is 0.25 of a litre. So we ask ourselves, how many moles should I add to 0.25 litres? Rule of 3, 1 times x equals 3 times 0.25. X equals, okay, that's cross multiplying, that gives us 0.75 moles. So the first thing is I need to add 0.75 moles of salt to that beaker of water, but I need to know how many grams 0.75 moles of salt is. So we do another rule of 3, but first of all we need to calculate the relative formula mass for salt. So we do that, we put MR for table salt is, for NaCl, is 23 for sodium plus 35.5 for chlorine, which gives us 58.5. So we can make our molar statement again. We can say, therefore, that means that 1 mole of sodium chloride has a mass of 58.5 grams. So we can ask ourselves the question, what is the mass of 0.75 moles? That's to say, 0.75 moles goes to x grams. We cross multiply, x times 1 is x, is equal to 0.75 times 58.5 grams, and that equals, calculator, 43.875 grams. Okay, so to make this 3 mole per litre solution of salt water, I need to add to 250 millilitres of water a mass of 43.875 grams of table salt.